evening everyone. The program is about to commence in a few minutes. All of you please be seated in the hall. The program is about to commence in a few minutes. All of you please be seated in the hall. Please be seated in the hall. We commence this program in a few minutes. Respected dignitaries, industry luminaries, our strategic partners and sponsors, and my fellow colleagues, a very warm welcome, good evening, namaskar to all of you. It's a privilege to welcome you to this landmark organization of 10th EEA. I am very honored that I can organization committee of 10th EEA, and I have the pleasure of being a host for the evening. The legendary management consultant Peter Tucker once noted that the best way to predict the future is to create it. Tonight, as we gather for this welcome agreement, that is precisely what we are about to do. Your presence this evening is a soft testament to the collaborative synergy that fuels our product. For 27 years, the steadfast commitment has been the catalyst of our evolution, and we are profoundly grateful for your continuing partnership. Today, we are honored to host an assembly of experts and innovators united by a shared vision for the future. As a stage for upcoming flagship programs, the institution's theme is both powerful and visionary. To commence the proceedings, cultural reverence, I request the assembly to please raise for the invocation of Hamdallah, a traditional tribute to our Tamil language and heritage. To commence on the program, we have curated two highlight sessions to address the most pressing challenges in our industry. Our first experience is titled Engineering Excellence, SchuF Customized Leadership of SchuF Valves. This open session directed Dr. Abbas, Managing Director, and the Digitalization Sales Manager, examines the sophisticated behind best valve architectures. This will be the first of our specialized presentation scheduled for the evening. Then we move to the hard meeting, the official curriculum advisor. This is the moment we are now waiting for. Position right in the program, which will feature the track meeting of flyers and brochures for 17th TICE 10th Engineering Excellence Awards. It's a prestigious ceremony where our visual performing officially takes place by representatives of esteemed guests of honor. Finally, we will for a technical session, which is titled Cordant, which was presented by one senior sales manager from Hughes. This session wants to offer wide insights on optimizing performance and advanced digital monitoring and how data science strategies are improving the life of industrial assets. On behalf of FP26, I want to welcome our speakers, guests, participants. We look forward to an engaging and informative technical session. It is with great pride that we are now steps in the excellence. This milestone commemorates our flagship event, 10th Engineering Excellence Awards, the 17th TICE Technology Innovation Conference Exposition, scheduled for the 15th of October this year. We look forward to the presence and continued support in making some memorable and successful occasion. On behalf of the Deputy Chief Committee, I take a moment to thank our sponsors, our sincere thanks to our partners, Mr. SchuF and Hughes. We greatly appreciate our customers, partners, KMMC, Golden Dama, and Moody. A heartfelt thanks to our platform sponsors, Aldora, Allah Engineering, KUF, Sasko, and we also thank our sponsors, Al-Bala Engineering, Al-Bala Exchange, Burger Brand, Eagle Burgoyment, Gulf Pacific, Hayes Cisco, Hyatt and Metronic Services. Finally, thank our sponsors, GGCC, RAN, Al-Bala, Ceremonial, Old Market, Malabar Golden Diamonds. We also thank our partners, SchuF Valves for their economic support. I take very much as I did this, the ISO 2006 from engineering organization in the region. Over the years, it has consistently conducted programs, the highest standard of professionalism, always prioritizing the safety and well-being of our members, partners, in every initiative we undertake. With this commitment to stay safe and responsible, it is my responsibility to share a safe moment for the day. Let's take a moment for the briefly. especially here and limited content regional way, while high temperatures are familiar part of our life cycle. As engineering and safety professionals, we must never let failure lead to complacence. Heat waves are volatile and hazard, and when temperatures go, mild variation and heat fatigue cause rapid cognitive function, significantly increasing the probability of critical errors as yard, plant, or other site. And looking at our immediate surroundings, please take a quick moment to identify the nearest emergency exits, which are on either side of the wall. And also request everyone to ensure that all walkways and exits remain clear of bags, cables, or any equipment. At the heart of the community is a commitment to value-driven growth. We strive to enrich our fraternity by blending contemporary engineering excellence with the enduring principles of our heritage, the Tirupur. We could revive heritage remains a constant source of strength and guidance, inspiring our members to live with integrity on the global stage. On this regard, the Cordant of heritage from the Adigaram, Delhi Sailaway, Tirupur number 467. Ending Tunil Kagamu, Tunil Ennum Ennu Vanakkam. ஒரு செயலை செய்ய ஆரம்பிப்பதற்கு முன் அந்த நன்மை தீமை விளைவுகள் சாத்தியங்கள் ஆகியவற்றை நன்றாக ஆராய்ந்து முடிவு செய்து செயல்பட வேண்டும். ஒரு முறை செயலை நிறைவேற்றிய பிறகு இதை செய்யலாமா வேண்டாமா என்று மீண்டும் யோசிப்பது தவறு மற்றும் பலவீனமாகும். Translation: think before you act, and once you have decided and committed to an action, reconsidering or hesitating afterward is a flaw. This is will emphasize the importance of careful planning, foresight, and critical judgment before undertaking any task. A person should thoroughly analyze the consequences, advantages, and challenges before making a decision. However, once the decision is made and the action has begun, wavering doubt, second thoughts, reflect weakness and poor judgment. And with that, we now move into the technical seminars, the very heart of today's evening, where learning, knowledge sharing, and meaningful discussions take center stage. To begin this first segment of our event, our first session is on the topic SchuF Customized Bar Solutions, which features a joint presentation of a company at the absolute forefront of high-end engineering and industrial design. To start the session, it's my pleasure to introduce Mr. Abdul Thomas, Managing Director of SchuF Valves. Mr. Thomas is a veteran leader who brings us an extraordinary global journey of engineering brilliance to our stage tonight. His diverse career began in Mosambique, Kenya, where he studied electrical engineering at the Mosambique Polytechnic before migrating to Germany in 1981. In Frankfurt, he qualified as a state-of-the-art mechanical engineering technician, quickly rising to become head of project management for SchuF Germany. Bridging technical mastery with the business excellence, he later earned his Bachelor of Business Administration degree from the Regency, Frankfurt. After successfully in SchuF India, he now stays as the entire region as the Managing Director of SchuF Valves. Solidified the position as premium provider of high-end valve solutions. Welcome, sir. To present alongside him, we also feature the Digitalization Shankar, who is an alumni of the prestigious ICT who joined SchuF in 2011. After mastering complex and organizational projects as a dedicated project engineer, he relocated to the Middle East in 2014 to spearhead SchuF's regional expansion. As a sales manager, his deep technical expertise and commitment to sustainable business innovation has been instrumental in driving massive business growth across the territory. Together, this dynamic leadership brings a comprehensive perspective from the high level of strategic management to precise technical execution to discuss customized valve solutions. They are going to be joining Mr. Abdul Thomas and Mr. Jayshankar. Yes, sir, the stage is yours.
Assalamualaikum. Vanakkam. Good afternoon. I hope everybody had a good day. You're all here. Thank you for coming and thank you for the invitation. And also for thank you very much. Now, let's get into this. So, SchuF is a family company that started in 1911. We are around 115 years old. We have a large portfolio, spread into chemicals, pharma, offshore liquids, marine, oil and gas, polymer, and refinery. Most of them we are very strong in polymer, oil and gas also, very strong in pharma, chemical, and refinery. So as you can see here, the headquarters is in Germany, Germany, 1911. And then the second one was in SchuF Island, the summer manufacturing site. And then SchuF India was the third site in 2000. And then we bought a petrol corporation in America, and that was established in 1968. And then we have Vanakkam, that is in Italy. And what was shown here, we have also a French company, SSRI, who deal with SchuF Valves and cryogenic valves. And we have active manufacturing plant in UK. So our portfolio, this is a spread, is categorized as drain and suspending valves. We have isolation valves, control valves, switching valves, spray release, and injection valves are special, and safety-related valves. So why they are not categorized according to applications? Because in all applications, and because we are a specialty valve manufacturer, you find all of this in the applications. Yeah. But the customer has a problem. We would allocate one of these valves to solve the problem. Yeah. It's started with the bottom of the valves. These are valves that are under the reactor, mostly polymer, to drain out the medium of the reactor. There are different types of them, the system, disk, and customers. Then isolation valves, we have lift part of the valves. These are also for valves, metal system. Three are actually double expansion plug valves, double block of heat, and then we have vital, hydrogen valves, and specialty valves as I see that are manufactured around. Control valves, our strategy is mostly in angle control valves for security services. Yeah, multi-stage also control valves, with gauge control, inline control valves, and outward circulation valves. These are special valves for protecting the pumps, centrifugal pumps, to maintain a minimum control. Then we have switching valves. These are mostly diverter valves, whereby you divert the fluid in different directions. It can be in any way. There are X multiple constellations depending on the timing. Then we have the switch plug valve, which is nearly the same as the other plug valve, the for isolation, but this one is for switching and also mostly for decoder, where you switch between the two drums. Yeah. The difference between our valve and other decoder switching valves is that ours is a plug head and a leaf plug, whereby the others are actually ball valves. Yeah. And the specialty of the leaf plug valve is that it lifts out of the system when switching, so that there is absolutely no friction. Whereas with the ball valve, you always have friction. That's the specialty of the valve. Okay, manifold selected valve is for metering systems where you have different lines coming in, and then you select one line to check the integrity of the well. Yeah. And of course, customize the valves with different types of configurations. Experience valves, these are special valves. Mostly the experience valves are for PTA, polymer, and they are for just cleaning the vessel or the reactor. Normally, to clean the reactor, you take a spray gun. Some people have to go inside the reactor and clean the reactor. These are two valves on top of the reactor. There's piston type valves. The pistons drive around 150 milliliters into the tank, and then spray and turn the same tank. And there is a distinguished spray pattern depending on the tank geometry. And in that case, you do not need any ability to go in and take time. Yeah. And also, it's got a double usage. It is for also spraying after rinsing. You can spray in antioxidant or anti-sticking agents, mostly for PVC reactors. Yeah, so it's very effective. The steam injection is the opposite of the spray valve. It's from the bottom of the valve to inject steam into the reaction, into the reactor. Yeah, when needed. Yeah. Then you have safety related valves. The line blinds. These are, I think everybody knows whether in the refinery or other processes we have to blind the line. Yeah. What's the difference between our blind lines and the normal blind? Where is that ours are automated, so you don't have to unscrew the blinds, pull out separate blinds, and then move the blind, and then put back in, which needs a lot of resources, human resources, and also cranes sometimes, depending on what weight. This can be done in one person, depending on the size, or two people, and it goes very fast. I can think of presentations of that. We have presentations of that, so in detail. Changing about that, as I say, is changes over. It's mostly safe valve. Yeah. So most of the time you need to have a two safety valves. Yeah. So that during maintenance you can change during operation from one safety valve to the other. It's a legal requirement. I don't know whether they wait it's why, but in Germany it is a legal requirement. Also in Russia it is a legal requirement. You can't have one safety valve, so you have two safety valves, and you have to change one between one and the other. Also, you can use the change of valve only for safety valve. Anything you want to change, if you want to change from one line to the other, you also do that. Yeah, it's not only for safety valve. So as I said, you can also change anything if there is a requirement. The emergency tank SchuF valve is also for ammonia and LNG. These are huge tanks whereby the valve is inside the tank. It does SchuF valve intrinsically inside the tank. So that if there is a spilling outside the tank, for example, during loading, the driver decides to take off while there's no pipe on it and it breathes off the line. This is immediately shut off inside the tank so there will be no spill. Yeah. It's also fulfill the EEA 665 requirement. You find that also these days in huge ships, cruise ships also that are gas propelled. So it's also a requirement in the ships. And then also customized valves. Yeah. So you can move a little bit into detail. So for SchuF, we take clogging very seriously. And all our valves, we check whether we do clogging and design to avoid any costs. So we need a lot of slurries. Yeah. And if you have a slurry medium, it could get fat. For example, you can see here, that's a planche and a ball. This is the normal way of training, but you have a big depth system. Yeah. So SchuF is concerned about such things. We always check out to see that there are no problems. That's our philosophy inside. Yeah. And the solution here is we have a rubber with a seat. It goes into the reactor, and there's no dead space anymore. You can see on that that's the ram. When the valve opens, it lowers. And immediately just goes to the branch. So there is no dead space, no pockets, no problem. So this can be done in any configuration. If you have a manifold with bottle and you have a slurry medium, you know definitely in time because of all of that space and pockets, the manifold will be blocked. So how do you do that? SchuF has a solution. So So this is really the same thing. So we do different type of valves. These are automatic valves. And then there's switching valves, as we see, mostly for coker or for refinery services, where you have also slurry and CTS services. Yeah, as you can see, it's a plug valve, but it's a plug valve, not a wall valve. So the plug lifts, that's what we call the lift plug valve, as I say, and there is no friction. We have a special valve, the raised cam valve. These are mostly used for volume services, where switching is required at very high temperature with temperature fluctuations. And it is a sort of valve, also non-friction, friction-free. Whereby it's single substituted. And when you switch, it moves away from the seat so that there's no friction. So that makes it the life of the valve is extended. So you have a longer lifespan. We have the long for boiler, intermediate, and continuous. For those who operate boilers, or once in a while, you have to blow out sludge. You have to also blow out the contaminants in the water at highest level, so that you have bacteria and no steam. And we have the valves also. The angle valve and my type. Control valves. So we have different type of control valves. We have the flow type. This is mostly for chlorine services. And as I said, we do take care of all the ills that come with controlling the flushing, vibration, that's variability. So we all very responsible. We have our own CTE program. We have the normal linear, and then we have the percentage. But SchuF also has other proprietary control characteristics we call it balance. So that is the middle one. It's between the linear and the 80%. So it's good for startup. So you would start up linear, and then when you require, then you go to equal percentage, and then continue. And as you know, sometimes that linear is not always optimal, because it does deteriorate on and off after some time later, and you know that equal percentage could go into linear. So we have a middle in between. This is our own calculation, so it's called the band. So you can see down here, as far as the trim is concerned, or the control disk, we made it from one piece. We have pins, for guidance, and we do not weld on the pins onto the disk. It is machined from one piece. So it gives the stability. Of course, we do all simulations to make sure that we have optimal conditions in the valve for avoid flushing cavitation. Yes, of course, we have all sorts of trims also. And then our preservation valve, as I say, this is a valve that protects the pump to ensure that there is minimum flow according to the pump manufacturer. So the customer will give us the pump curve and conditions, and we size it accordingly to make sure that the minimum flow is guaranteed when there's no requirements in production, because the centrifugal pump keeps on moving, and if you don't have any flow in it, it will overheat, and it's a very expensive equipment, and get damaged. So how it works is got a check function from the inlet That's the inlet of the pump going out the outlet, and that's going through the process. So when the requirement is there and the pump has maximum pressure, it opens up, lifts up the check valve, and at the same time, the bypass is closed. So the flow in the bypass is the proportion of the pressure difference. Yeah. So when you have a straight flow and you have maximum requirement in the plant, the bypass is closed. Yeah. You could also do this with a normal control valve with positioner, but you know that would fail. This is the sure way that it's not good fit because it's pure mechanic, and it always protects the plant. So this is how it works. The first time you can see the process, the flow is going from the pump to the bypass. That's full bypass flow because now there is no requirement from the process. The check valve is closed, yeah, and the full flow is just the minimum flow flowing. And then where the process needs more, the requirement goes higher to the process, it starts lifting because the pump now pumps more, and the differential pressure then between the inlet and the outlet, the check valve opens, there's the crack point, the cracking point overcomes the cracking point, and the check valve starts opening. You have then dual flow. At that moment, part of the flow is going to the bypass and part of the flow is going to the process, depending on the process requirement. And then when you have full process requirement, the check valve is fully open, and you don't have any bypass flow, and now you have full process completions. So switching valves, as you can see, yeah, this is mostly for decoder, where you switch between the two cover drums, yeah, and you can see it's a lift block valve. You have two actuators or three sometimes, one for lifting and one for turning, yeah. The top one is for turning, and this one, the one down here is for turning, and that one is for lifting. So first you lift up the plug off the seat, and then you turn, yeah. So there's no friction between the seat and the plug. Yeah, it gives it a very long life because there is no slurry in between the body and the seat and the plug. Yeah. We have a line of defense. There's a flushing valve. We put a valve there to flush. The important thing is that you only flush while you switch, unlike the wall valve where you have to constantly flush with steam. Yeah, here you only flush when you operate the valve and switching. Yeah. That reduces your requirement for steam and just the cost.
Can you go back to the slide, please? Have you supplied this kind of a wall with three actuators? Can you remind this?
The most is two actuators because lift and turn. Yeah, you have two actions. You can also have it with one actuator. That's a special actuator. Some customers want one actuator, they say, oh, I don't want two actuators. Yeah, so there's an arrangement, yeah, and an indexing mechanism that lifts it and turns it. Yeah, and then seats it and turns it again to close. Yeah, so it's called LTS, lift turn switch actuator. Yeah, so depending on the requirement of that customer, you could have one actuator with a LTS mechanism, or you can have a traditional way with two. There's no other way, because you can't have one. These valves are very big also, and very severe service, so you need to have two actuators today. Yeah. Not like I just showed the raising strong raising stem ball valve, but also it does the same thing, where the ball is first moved away from the seat and then turned. That you can have a groove in the stem, yeah, that does the turn and lifting. But at this level, you can't do that because that would be a very big groove and the forces there, the power will be just too much. Yeah, and the cabin will be just too high. Yeah, so we can't do that. So we have to do 2 actuators or 1 actuator with the LTS return switch mechanism, which is actually a gearbox-like thing with indexing. Yeah, so that we can do the turn. Yeah, and the lift. We have supplied to Husky, I don't know if you have heard of that, in Canada. Yeah, replaced a boiler, and it operated for 7 years. They removed the valve, stripped it, didn't have anything, did not replace anything, assembled it with that. That's how it shut down. It's got a very nice time. I'm not exaggerating, of course, but I'm not exaggerating. It's just because of the mechanism and because of the process. There's no friction, and it's really friction. Yeah, and that does. Whereby, wherever you have friction, you know, you cook, there's lots of solids. Yeah, so it's very severe. Excellent. So we have, we call it the 3 line of defense. Yeah, the first line of defense is the lifting and the turning. Yeah, and then we have those are the 2 line of defense. Yeah, and then the 3rd line of defense is the flushing. Yeah. This is the flushing port. Yeah, because I will flush the valve in here, and I'll tweak that valve. Yeah, and this flushes, and you can see the retrofit. So, can you hear me? Yeah. I'll repeat. So you have a flushing port there and another flushing port here. This is the 3rd line of defense. Yeah. So where switching, you put in your DCS program in such a way that now you're switching, you start flushing. Yeah. And this is going to flush around the plug. Yeah. And here we under the seat, and there will be no friction. Yeah. And while sitting again, we are lowering it, you flush again. When it's over, you don't need to flush. The medium passes, you switch to the next drum, and when you're done with that, you want to close, you flush, and then you switch it again, lower it, and that's done.
How do you confirm any code is positive?
There's no copy positive because everything is flushed out. So if you want to check and do maintenance, you can, okay, this is the inlet. Okay, you cannot do that here with this one, but with the isolation one, you can remove and see whether there's coke there. But we've never had problems like coke residues on it, because the flashing is enough. Yeah, and these 2 flashing poles, and you put a 3rd one there if you want to also. Yeah. So yes, fish.
Because every other company in the world is supplying one or specific application.
So the history behind it is a big history. I don't know whether there's any involved in manufacturing. I hope it's not offended. And I'm not saying it's just because of SchuF. This was the valve that was used at the beginning in the coating industry. It was a plug valve. For some reason, the plug valve manufacturer, SchuF was the inventor of the plug valve, by the way, did not follow up on it. The ball valve manufacturers spec in the ball. They were very aggressive, and that became the norm. So that's why ball valves are spec in. But at the beginning, they were plug valves actually. So that's the difference. Yeah. And the difference shows itself in the lifespan. And it's been proven. Yeah. Whoever wants, we can give references. Flight Canada, you go ahead and pick it up. Yeah. Before the war, we had lots of them in Russia. We don't supply now because we're a German company. Yeah, it's restricted. But most of the coal plants in Russia are plug valves. Of course, we love competition. Ball valve will continue. Yeah, but we are fighting now against the ball valve because we're not standing. Yeah. So we hope that slowly that we can expand it. Yeah. Does it answer your question? Thank you very much. Okay, I'll continue. So, as I say, SchuF prides itself in that we are concerned a lot about quality. If you have a manifold, as I say, here you can see pipes and a ball valve. It will fall. You see the black, that's material problem. Our solution, you have a divider valve, it's a compact valve. This is one whole valve. It's a body with pistons. Yeah, and it closes here at the seat. Yeah, you can see that that's missing there. Yeah, that's not a problem. Yeah. So when you open the valve, you pass the medium, nothing, no residue. You can open both sides if you want. Yeah. So this valve come in any configuration you want. There are some craziest configurations. Yeah. Yeah. Of course, there's some limits because of the angles coming. You have limitations, but we try our best to match whatever configuration that is required. It says Shenhua. I don't know if anybody knows Shenhua. It's in China. It's cold liquefaction, direct cold liquefaction. Normally you have the indirect cold liquefaction where coal is first changed to gas and then gas to oil. So the Chinese came up with this old German technology, direct coal. That means you refine coal direct from coal to oil, which is really tough at very high temperatures and pressure. And under one of they had 4 trains. Yeah, you can see this is a diameter valve here with 4 pistons, 4 outlets and 1 inlet. Yeah, from the vacuum tower into the valve and then the 4 trains. Yeah, and because it is cold, there is no clogging at all. The pilot plant was in Shanghai. It was producing ball valves. They started it within 2 hours. The plant was formed. So the cake was an brilliant solution. They actually, at the first instance when they commissioned, they did not have storage for oil. They had shut down the plant. It's running now. We don't know phones, they are not telling us anything now, but anyway, that's how it is. Yeah. So line is also very important for planning. Yeah. So as I say, if you have to maintain a pipeline and you isolate, you have a spectacle to show the people who maintain that now it is safe, the line is depressurized, and we can work with it. I think most of you know the spectacle. Yeah. So most of the time when they start work on the line, they have to remove all the bolts, pull the flags apart, which is very difficult if it is a big line. But you do that for a 48-inch or 24-inch, yeah. And then remove the spectacle, which is very big, and for a bigger valve, bigger line, and then turn it around. Block it, and then do the same thing again, put it back, and now the maintenance people can see according to the position of the spectacle that the line is safe. To do that will take you like 2 days if the line is big. We are promising you that you can do that for bigger lines within hours, with less resources, and work can continue. So how it works? We have a car mechanism. Yeah. You can see which turns. You just have to turn the handle, which turns the car mechanism. there's a city carrier, you might see the drawing, that separates the line. You can then turn the spectacle, put it in place, whether you want it open or closed, turn the handle in the opposite direction, and it's done. Work can continue. It's that simple. So for small valves, one person can do it within 2 minutes. Yeah. And there it is. So there's the spectacle. So there's the open position. You can see the spectacle has got no bow inside. That means the opposite of the spectacle is got a bow. So this line is open. It is medium passing. Now you want to switch because of maintenance. You just turn the handle. It separates here. You can see without removing the flanges. Anything. The cam mechanism will separate, and you'll be able to turn the spectacle. Put it in the closed position. You can see now the signal is that the spectacle inside is blocked because that side is open, so the line is safe. So we have all sorts of versions. Yeah. We have a sliding type depending on whether you have space or no space. Yeah. They can be automated. We can put a strainer inside. Yeah. We've got a fire safe version and we've got a non-spill, and if it is not reachable with extended actuators. Yeah.
This is applicable for RTJ plus.
Yes, you can. See, the thing is that you don't need to, if your flange is an RTJ, you will get an RTJ. If you want welding, you can get welding. Yeah, but that doesn't make sense. Cool. But otherwise, any flange you want. That's not a problem. Yeah. Changeover. You have here 2 safety valves. Yeah, as I said, you need to change from one of to the other because one needs to maintenance. Yeah, you can do it during the process. That's not a problem. You change over to the other one. So the valve is a disc valve. It moves to one side, closes, shuts down the other one side. This side is open, so you can go on with your process. And on the other side, you can remove the safety valve. Yeah. This is the tank safety valve. It's according to API 625. For different type of tanks, it shuts the tank inside the tank, intrinsically. So depending on the tank shape, you have the big tanks, you have cigar tanks, spherical tanks. The valve also changes a little bit, the design of the valve, but does the same thing. Yeah. This is in Kuwait, KOTC. Yeah. We supply, I think, 6 of them. Yeah. And yeah, this is the valve. This is the actuator. The yellow thing up there on top of the valve. You have this is the top of the tank. You have the spindle going all the way. It's got weights. This is the bottom of the tank. Here is the flange going outside. And this is inside the tank, and you have the disc here, so it shuts inside. These valves are always open. According to your shut-off emergency plan, it slam shuts using the weights. So it's guaranteed that it's going to close. The actuator is just for keeping it open. It holds it open. So whenever there's an emergency, according to your ESD, you take over the signal, and these weights will just close the valve. So you're sure that it's going to go. The problem is how you open it if this link breaks. You can't get someone to swing into the tank and open the tank. It's shut forever. You can have a redundancy span at different configurations. Yeah. So we can make a solution for that. It's not a problem. customers. Thank you very much. Yeah.
Good evening to all present here. Thank you, Mr. Sumas, for your detailed presentation of the SchuF products. So I am here to take a presentation to the next set of slides. So I am here to present a topic on the usage of SchuF valves and technologies in the sustainable and the renewable technologies. So as we have seen from Mr. Sumas' presentation, we have a rich history of supplying to legacy energy and petrochemical sectors, and also as the world adapts to the fossil fuel dynamics its costing, that it is trying to minimize, and it's also finding new pathways to ensure the energy security as well as food security for the growing population of the world. There are new technologies that are coming up, new technologies that are being devised by technology licenses, as well as new demands for fluid control as well as process control in these technologies. So SchuF have always prided ourselves in being adaptable, being flexible, and also leading the technology in valve flow control business. So, just a brief about sustainability. We all are aware of the three different modes of sustainability, which is reduce, reuse, and recycle. So, what does each of these mean for process industries and for our energy and petrochemical industries? So, reduce can be broadly classified into reducing the energy consumption, reducing the feedstock consumption, conserving the resources, and reducing the utility consumption, water and steam, and also reducing the waste. Yes, so this is that amounts to improving the efficiency of the processes, as well as to make the overall process more environment friendly, and also for it leads to a sustainable and less waste, leads a better future for the generations to come. Yes, so the reuse again in terms of process industry, reusing the heat, reusing the whatever waste resources, trying to minimize the reuse in terms of processing and then using it again. Like how we already use in petrochemical refineries, we are reusing the heat by in power plants, especially we are using the heat from the gas turbines to heat recovery steam generators and then running steam turbines. So this is one example. And also reusing the produced water for less intensity. For example, even new process or reverse osmosis plants, we are reducing the water discharge. We are moving into zero discharge technologies. So these are having less of an impact on the environment. So this is our target, and it is a recycle. Plastics we know are indisposable in our day-to-day life, but also the disposal of plastic is a problem. It's not just a problem for industry, it's a general problem for society. So there are companies that are innovative in processing this waste plastic, making sure that it doesn't end up in the landfill or the river or into the ocean, and the process of recycling, making use of the plastic, making use of products out of it is also up and coming emerging sector that deserves become attention on its own. So also another reuse that we are seeing, recycling that we are seeing nowadays is the recycling of the batteries that is also becoming more widespread in terms of electric cars, in battery storage, big levels of storage facilities, and also domestic level storage batteries. These are having a definite life cycle. It is improving as well, but what about the cycles or the batteries that are already out of use or unusable? So there are ways that we can recycle the materials from it, the precious metals, minimize the amount of mining required by reusing the metals from the waste batteries. So these are also different technologies, and we are working on them. So in this slide, I will just give a brief of the how I've already progressed, and also open to any tasks that may come out in people working in these type of sustainable practices. So we can see for every sector that we have, similarly every sector that industry that we have, there is already major or at least leading alternative in terms of sustainable technologies. So you can see in aviation fuel, we are already looking at making sustainable fuel from biomass or from vegetable oil and many technologies that require new types of refining and different type of refining from the petrochemical and the oil and gas refining that they are used. So those bring up new challenges in digitalization and design, and we are working on that. And there is also the energy fuels. So there is already LNG that is moving. The energy is already moving away from the heavy fuels of oil, and they are moving into LNG tanks. And even further, we can go into green ammonia. These are cost-effective fuels for shipping, which could actually reduce because maritime fuel and aviation pollution which is more than the percentage of the overall pollution to us. They are high impact sectors, and new technologies can improve the carbon footprint and the environmental impact. And these technologies becoming more widely good and high efficiency power generation. So power generation also the old thermal power generation. Fossil-based technology, but we can improve the efficiency, and by improving the efficiency, we can reduce the consumption. So I will go into detail about how we are doing that in certain case studies. In steel production, we are also working with major steel producers where they are using direct reduction of iron by hydrogen. So they're using. And finally, fertilizer production. So fertilizer is very important for food security for the growing population, as well as it's a geostrategically important. Produce locally sourced raw materials for fertilizer could also be a very important topic for countries as a whole, as well as for users who are looking to secure their supply chain for the future. So locally producing ammonia from green hydrogen or using carbon capture to offset the carbon production of the fertilizer is one way to decarbonize. So you can see here the first is plastics recycling. So there are two ways to do it. One is physically grinding the plastic and processing it, and the other is to chemically process it. So these new technologies are demanding higher temperatures, higher pressures, higher process integrity, higher process control, and we are working with some of the leading startups in this sector like Hughes Technologies and NatureWorks, and we have already supplied our divert valves for the slow flowing sludge. So we are designing and supplying divert valves to them that are not only dead space free, but they also avoid slow spaces. So even a slow space like a linear contractor in one of the piping could lead to process disruption. And we have designed, we are also supplying to leading battery recycling technology providers in cases altogether. So this is one in the crystallizer facility where they recycle and process the lithium from the batteries, looking into other highly metal like cobalt processing plants, because we have history of supplying to the mining and the processing in the upstream side of this. So we use our technology, our experience in handling studies with heavy metals to aid them in designing more thorough and more efficient processes. So the next is we have supplied essentially automatic valves, and also we have supplied some critical control valves. So Umico, Transnational, Agrovar, these are industry-leading experts in the mining and also metal reclamation industry. So we are working with Nexion as well in the UK. So they are having technology that will improve the battery energy density, and they are able to provide special valves for them to make the volume that they have, that they can use in their batteries to improve the energy density as well as reduce the range for a car. So for passenger cars, reduced range in batteries means that longer range, more efficiency, etc. So the next is the energy vectors. We have So we have the traditional indicators of LNG, energy transition, and shipping. So we, as mentioned, we also have on the energy handlers, as well as in the cruise shipping, as well as energy fuel. And we also have other data that we can supply the energy chains, and control valves, as well as on the digitalization. Moving on, we have supplied we are working with energy and the process technology as an internet, and we supply them our proprietary models or the technology for the CO2 studies, also something that the conventional so we are using solutions for these technologies, and we are also supplying working with the very high engineering of supercritical CO2 conductors. So what is supercritical CO2? It is a CO2 in liquefied form that is a good carrier of heat that used as an alternative to steam, and but it is extremely difficult to handle. It is being at a very high pressure and high temperature. So the supercritical CO2, the valves used in supercritical CO2 lines have to be extremely robust, have to be precise, as well as have to means extended lifetime. So this is the usage of process experience. But the main product is that supercritical CO2 conductors as the footprint of the CO2 turbine will be much smaller, the efficiency is much higher because the thermal efficiency of the supercritical CO2 will be high capacity, and it leads to a smaller, more efficient plant. So they are more modular, they can be easily expanded. Is facilitated because of the capital costs, except for the turbine usage at the moment, would be expensive, but the associated balance plant would be smaller, would be smaller than the supercritical usage. So we have control valves that we use to advantage of this technology, and we have some successful problems and we see uses of these. So this is about the products. Finally, sustainability roadmap for users as well as for many products electricity. So the initial phase is to take stock of the carbon footprint, to completely categorize the process as mandated into reducing the carbon footprint, and then implement them not only in one go, but step-by-step processes that it doesn't hurt the bottom line, or because of obviously nobody wants to trade sustainability for profits or efficiency. So it can be done, and it's a staggered process, and we are available to discuss any such requirements as we have, or to go with any process technologies that are from the device and develop the demanding application. So this is my presentation. Thank you very much for your patience.
Thank you to the nations of Thomas for the wonderful presentation as an engineer. So he said to bespoke architecture sustainability has provided a solution of technical industrial organization. May I invite the regulations to come back on the stage for a very quick question and answer session. Does everybody have any questions? We'll have a very quick question and answer session for moving on to the graces. Yes, we have. Can you for the gentleman, please? We just take a couple of questions before moving to the graces.
Good evening. Nice presentation. Just I would like to know more information. So this is online blind. It's what we are doing. Are you going to do any factory on the pipeline, or you are going to utilize existing plant spaces, or how?
Okay,
it will be intrinsic stability
for the line.
Yes.
So because the line is a valve, it's sort of a body. Yeah. You will have to match it into your pipeline. So you will have to do some modification. The pipeline. Because your flat, if you can imagine, it's not like this. This is a flat. Yeah. But because this is a valve, this is. Yeah. So you will have to cut the line to match the valve. it's better long term that your cost of ownership goes down. Yeah, that's the benefit.
Oh, thank you.
Any questions?
My question is regarding your product and laws. You know, 886D says that double block bleed and double isolation bleed. I want to know your product is meeting both double block bleed and isolation.
So it depends on which product you're talking about.
Any one, I came from the question I have some psychology.
So also for isolation, we have double block bleed. We don't make all of it, double block bleed. We don't do that. And the resistance of the special is for switching. Yeah. So it's not an association. But what we're not showing here, I think we have a double block bleed, expandable dual valve.
Yeah,
that's double block bleed. If you want more, we can discuss that in the break.
Okay.
Yeah, you can give more information.
Yeah.
Thank you. Thank you.
I think that's all the questions. Sir, I have a question. Yeah.
Take one more question.
Good evening, sir. I was a presentation about the walls. So I just wanted to know about the automatic resuscitation of walls. So how far it is reliable and I mean, is it well-known, installed everywhere?
Okay, so Dinesh will get that.
So the automatic resuscitation valve, as I explained, is custom for the pump. So we design the valve, the internal of the valve will be resuscitated based on the parameters of the UCC design stage. So it is a mechanical valve and there is no intervention required. So when you want to reliability, this is 100% secure. So even the valve for some reason or due to some reason the downstream pipeline, if there is unexpected behavior in the flow, this valve will always will discharge at least the minimum stable flow of the pump. Even when it is completely close to the main line, the bypass capacity is greater than the flow, and the combined high flow as well, the inlet or the main line flow or bypass flow is greater than the main flow. So at all times it is protected.
So from energy point of view, any special consideration there?
From energy consumption point of view, this is a really startup valve. This is what we have seen in most cases is used for startup, where there is low, for example, oil feed or the fluctuation in demand is not that high. So once you start up, we need to build the pressure into the flow, and during that time we will be diverted to the bypass. And once it starts up with enough pressure, then open completely, and then unless there is any control or any turn on the downstream side, the bypass is not active, so it is actually fully discharged into the main line. So there is no energy loss. It is only lost when it is starting up or when there is a shutdown or rundown on the main line. But that is intentional, so this is also not considered as energy loss or non-operational bypass.
Thank you.
Good evening. This is reliable valves. I would like to know what are there any limitations for this valves? Like what is it? Up to what size, what temperature, what pressure these reliable valves can function?
So I was just explaining the range that we can do. So we can do from 1 inch and 400 or ASC 2500 class. We can do, it's not only 100 motors, we can do up to 7 or 8 different motors depending on the process requirements. The larger sizes, we would say the largest that I am aware of is around 24 inch. This is for a slurry mining application where they have 4 or 5 different, I think it's 5 different pumps that are connected to a single discharge, and the liability we use that there was 24 inch 140 rating. So it's a mixed bag. It depends on your requirement, number one. The space availability is a brownfield installation. The space availability is also concerned. But we can definitely have a specific location and the application might can get related. But size for sure is not since we are a customer manufacturer, we can go to the full charge and larger. But particularly the type of applications are not that big again.
We can also do class outside which is done. Yeah, for the power electricity, it is possible. I think it. Yeah. for supercritical critical power plants also there.
Yeah. So you have reference over this in the area.
Yes, we have installed in Orange here in Qatar. So we have tools for installed more than 11 years service, and we are very good relationship with them. So we subsequently we expand our portfolio of Orange as a performance for the area. Because we use the tax slurry, it is also difficult to manage. We also have in Arabian company in Saudi Arabia, we have Sadara in DTI. So very demanding applications we have preferences. It's not big as well. So we are ready to expand and we are open to any requirements that we can do.
Just the bulb can be, it can have cooling. We can have a jacket on top of it if you want to cool the medium, or you can also use the jacket in the medium. Yeah, so you can have jacket, or you have just for like a ticket without a jacket on it. So those are the possibilities.
Thank you.
Thank you, gentlemen. May I introduce you on the presentation? It's now time for presentation speakers. May I invite our President, Mr. Rajan, Mr. Stanley, our General Secretary, to come on the stage. I invite our President to present the show. I invite our General Secretary to felicitate Mr. Abdul Kadari. I invite our President to felicitate Mr. Vignesh with the show. Mr. Vignesh.
Thank you very much.
We just have a moment, few more seconds.
Thank you very much.
Thank you, gentlemen. With our first technical session successfully concluded, we pivot from the presentation to the celebration. It's now time for the official curtain raiser of our TEF 2026 calendar. To walk us through this brochure launch with upcoming milestones, I'd like to call upon our host for this segment, Mrs. Maitri. Over to you, ma'am.
Thank you. We are truly delighted and honored to have our esteemed guest for the evening. And as a token of our respect and warm welcome, we would now like to present bouquets to our distinguished guests. Guests, esteemed dignitaries, respected leaders and members of Tamil Nadu Engineers Forum. A very good evening to one and all. I am Maitri Rajamanna, VP Enterprise Product, National Bank of Kuwait. I am part of organizing committee TEF Kuwait 2026. I will be the host for the curtain riser segment. It is with great privilege I welcome you all to this prestigious occasion. We gather here to mark a significant milestone, the curtain riser for our flagship event, the 17th Technological for TICE officially marks the commencement of all activities related to TICE. We are truly honored to have a distinguished gathering of industry leaders present with us this evening, despite their busy schedule. We sincerely thank all our distinguished guests for gracing this occasion and being part of this important milestone. On behalf of 10th Kuwait, I extend a warm welcome to you all. We commence today's significant occasion with National Anthem of Kuwait, followed by the National Anthem of India. I request all of you to please rise. To deliver the address.
Good evening, distinguished guests, respected dignitaries, esteemed speakers, valued sponsors, industry leaders, members of Tamil Nadu Engineers Forum, Kuwait, ladies and gentlemen. On behalf of Tamil Nadu Engineers Forum, Kuwait, it gives me immense pleasure and pride to welcome you all to this prestigious anniversary event for the 17th TICE Technological Innovation Conference and Exposition and 10th EEA Engineering Excellence Awards. As 10 proudly commemorates 27 years of excellence, today's gathering stands as yet another milestone in our journey of fostering engineering knowledge, professional excellence, innovation, and community collaboration within Kuwait and beyond. We are deeply honored by the gracious professional sector and industry service continue to inspire professionals across the region. We sincerely thank you for joining us this evening. I would also like to extend my warm welcome to our distinguished keynote speaker, Mr. Keynote, Manager Projects from KBR. Your presence and your willingness to share your expertise add tremendous value to this evening, sir. We are greatly privileged
and thanks for giving a brief about the TICE event to all of us. Moving on, it is now our distinct honor to invite our chief guest, Mr. Omar Ahmed Al-Mola, Manager HSC KNPC and Acting Manager HSC Kipik, to kindly grace the dais. May I request our President and General Secretary to kindly accompany him onto the stage. Before we move on, I also request to play a short video about the rich legacy of innovation and excellence.
27 years of excellence, 27 years of innovation, 27 years of unity. Welcome to the journey of Tamil Nadu Engineers Forum, TEF Kuwait. Welcome to the inspiring journey of TEF Kuwait. It all began in the year 2000, a spark of connection among engineers from Tamil Nadu, India. What started as a simple idea to unite professionals abroad soon became a vibrant forum, a trusted ISO 9001-2015 certified non-profit organization built on passion, purpose, and professionalism. TEF became more than a forum. It became a platform for knowledge sharing, technical excellence, and professional growth. Through every seminar, every event, and every initiative, TEF inspired progress, empowered engineers, and connected industries. In 2010, TEF launched the Technological Innovations Conference and Exposition, TICE, a groundbreaking stage where ideas met innovation. From pioneering technologies to inspiring partnerships, TICE transformed Kuwait's engineering landscape, and to honor brilliance, in 2016, TEF introduced the Engineering Excellence Awards, recognizing achievement in engineering, those who lead by example and light the path for others beyond engineering. TEF built a vibrant community, connecting minds, nurturing talent, and fostering friendship. From exhibitions to business forums, from students to senior professionals, TEF became a bridge of collaboration, celebration, and God. Through the years, 16 conference, 570 plus exhibitors, over 10,000 participants, and 375 plus speakers have joined this remarkable journey, each one a part of the TEF legacy. 2.5 decades later, the spirit remains the same, strong, united, and forward-looking. As we celebrate 27 years, we celebrate every engineer, every idea, and every achievement that shaped this remarkable journey.
Now may I request our President and General Secretary to accompany our chief guest, Mr. Omar Ahmed Al-Mola, onto the desk. Ladies and gentlemen, the moment we have all been waiting for has come, and may I request our chief guest, along with our President and General Secretary, to kindly proceed with the ceremonial curtain-raising event, officially unveiling the brochure of TICE 2026 and 10 Engineering Excellence Awards. Mr. Jasper Manoli, who is not available here in attendance, and on behalf of him, I request Mr. Shyam Manoli, Industrial Establishment, Dr. Abdul Hadi, Dr. and Mr. Nasser Al-Hajri, along with the keynote speaker, Mr. Christopher Ba, onto the stage to receive the first copies of the brochure. We also request all our former President and General Secretaries of TEF to also receive the first copies. I request you all to please come over to the stage. Time for the inaugural address. I request our chief guest, Mr. Omar Ahmed Al-Bola, to address the gathering.
Good evening, everyone. I'm not supposed to say anything tonight. I'm just supposed to attend and enjoy your efforts and see this beautiful gathering. But I have to say two things. First of all, I'm impressed by my friend, Mr. Fasil, Maria, to come here, so thank you. I really enjoyed my time. Second thing is that I see that every time I join this conference and see these faces, I don't see it only here, I see that work among my friends and colleagues that work who are part of your association, are adding a lot of value, adding a lot of contribution, they're adding ideas, and they are supporting the efforts of Kenya companies to improve their performance. You are not just an association, you are a partner of business and you are your friends in life. I go way long, okay? My father speaks Hindi, I don't, okay? I speak a little bit, but I don't want to say a word. Anyhow, I really enjoy this conference, I enjoy these moments. And please keep it up, because it's adding a lot of value to our community, to our companies, and to the community itself. You're investing in your community also. And we'll enjoy this pleasure and enjoy your community. Thank you very much for your time, and thank you for your
Thank you, sir. I request you to please stay on the stage. As a token of our gratitude, firstly, thank you for your inspiring speech, sir. And as a token of our gratitude, we request Mr. Raja, Mr. Krishna Kumar, and Mr. Vasudevan, along with our President and General Secretary, to felicitate our chief guest. We now move on to the keynote addresses. Please join me in welcoming Mr. Christopher, Manager Projects, QTR.
Good evening, ladies and gentlemen, distinguished guests, and the leadership team from Hyatt, and my colleagues who are working with the who invite me into the CC. Before I go into technical presentation, I want to take a moment to acknowledge the remarkable organizations today and who are it was new to me a few months back. So what I've learned about TEF, the scale, the depth of the association, that's truly impressive. Bringing together 56,000 engineers in such a diverse range of disciplines across Kuwait industrial landscape is no small feat. I'm fascinated to see how TEF serves as a powerful forum, uniting the alumni of India's premier institutions while maintaining a strong registered presence in the Indian emphasis. Stepping into your 27th year is a milestone and speaks volumes. It's not just a number, it's a testament to the legacy of commitment, consistent technical learning, and a renewed sense of community. Your flagship event, TICE, is clearly evolving into a premier platform with innovation in industry, innovation that we in KKR resonate with very deeply. I'm personally delighted to be part of today's coverage event, and that as a new energy movement with the new year of technical ambition is under witnessing the fire launch and the official announcement of 17th TICE and 10th Engineering Excellence Awards earlier this evening was truly inspiring. This is clear that 2016 is not just a conference. There's an blueprint for the future of engineering region. Being here at the inception of the site allows me to trust and the dedication of those to maintain such a high pressure. I just want to reflect. Some of my guys asked me, said we discussed innovation, and I want to share that in my experience for a long time, innovation about people and drive. I've done lots of projects that have lots of innovation, and it's always about people and drive. At KKR, we deal with complex engineering, and we don't do it in isolation. We're currently working on bringing AI into management. We've got industries where we're putting the best into one. These innovations are driving us. It stands out most of the tech excellence with mentorship and social responsibility. And that plays into creating space like this, where professionals can exchange ideas and nurture the next generation. I sincerely appreciate that 2026 committee invited me to be part of the launch, and it is an honor to witness such a vibrant community of engineers come together to drive our process. With the spirit of innovation and collaboration in mind, I will now move into the 10th section of the evening, and let's explore how we create value excellence and apply it to the shared industry challenges. Thank you.
Keynote. I request you to stay on stage. I request Mr. P.P. Muthu, Mr. Raj, along with the President and General Secretary, onto the stage to facilitate our keynote speaker. Thank you all. We now invite our guest of honor, Mr. Sabah Executive Director, to share their views. Thank you, sir. I request Mr. Bala and Mr. Bala KBC along with our President and General Secretary on to facilitate our response on honor. Thank you all. Now I invite Dr. Fahaheel, TL Production Operations QC, to share a few thoughts with us.
Leadership team of TIF, distinguished guests and fellow professionals. It's an honor to be part of this significant milestone as we make our country the 17th TICE and the 10th Engineers Forum. When an organization enters its 27th year of continuous years, it ceases to be just an association. It becomes an institute vital important to the living. Engineering is not merely about evaluation and project analysis. It's about building the future. What interests me most about the Tamil Nadu Engineers Forum is your unwavering dedication to continuous technical learning and innovation. By creating platforms like us, you ensure that global business practices are translated into local corporations and XYZ community. I want to commend the TIF 2026 Committee for their exceptional efforts and organization structure to all the members. I offer my hardest congratulations and blessings May this upcoming cycle bring forth groundbreaking innovations, stronger collaborations, and unparalleled professional success. My wishes are always with you. Thank you.
Thank you, sir. I request Mr. Ceremonial and Mr. Venkata from KOC along with the President and Treasury Secretary to felicitate Dr. Abdullah. Thank you all. I invite Mr. Nasser Al-Bashiri, Team Leader, Associated Gas Operations KOC, to offer a brief address.
Entering your 27th year and magnificent takes immense discipline, leadership, and shared visions, sustain and prepare of nearly 600 engineers with such a high standard of professional interactions. Your flagship event is highly honored competition as the primary platform for industrial collaboration and knowledge sharing. I want to strengthen my personal reasoning and congratulations to the 2026 team for putting together this flawless proposal and match. You are setting a benchmark for what professional solidarity should look like. I wish the entire world the best for the main event in October 15 and for all of the future endeavors. Keep driving excellence. Also, I have special thanks to Mr. Venkata and all the valuable guidance for us to be here this day. Thank you so much.
Thank you, sir. I request you please stay on the stage. And I request Mr. Cordant and Mr. Regency, along with our President and General Secretary, to facilitate Mr. Nasser Al-Bashiri. I request Mr. Fahaheel to join them on the stage. move on, we invite Mr. Shyam from newly industrial establishment on the stage. I also request Mr. Muthukumar, our President and General Secretary, to come up on the stage to facilitate Mr. Shyam. Thank you all. With this, we come to the conclusion of this memorable cultural event. As we look ahead, we eagerly anticipate the grand celebration of innovation and excellence at TICE 2026 and the 10th Engineering Excellence Awards. We sincerely thank all our esteemed guests, speakers, and participants for gracing this occasion and making it a grand success. We request you to kindly mark your calendars for the main event, which is about to become conducted on the 15th of October 2026, and we request all your continued support for all in-depth activities. And with that note, I would like to hand over to Mr. Suresh Anand, who will continue with the final segment on the second topic of today's technical seminar.
This is my new processing of the state, so for the evening. While the first session focused on the position of physical assets, we now shift our attention to the digital pulse of the modern industry. Our second technical highlight explores the power of intelligence and operations. We are pleased to talk about the body side says that the Hughes modern solutions is presentation that are journey called asset exams are how we can leverage analytics to transfer asset management. It's a distinct income highly accumulated in the energy and job sectors over decades of experience. Currently, the serious investment of Mr. Walter has a list track record of managing complex vibration systems for major oil plants worldwide in the region. Built on a solid foundation electronics and communication engine, Mr. Walter has a plan to rigorous on-site solution in Oman, to strategic space contract management. They bring a 360 plus to the industry restoration. Please join welcome to Walter as he shares insights of our welcome.
Assalamualaikum. Good evening, everyone. Thank you for the invitation for this event, and thank you for the introduction also. My name is Saeed. I'm part of the Hughes, part of the Cordant, the association partner. So I will just before starting the presentation, I will introduce right side, this is the oil field service equipment, which covers the upstream section, wellhead construction, completions, etc. And we have the industrial energy technology where it has the energy equipment solutions, services, where we're supplying the gas turbines, turbines, compressors, including services and maintenance, and also our portfolio equipment solutions, industrial solutions, doing maintenance and monitoring the machines and assets. So today I will be presenting the Cordant Asset Health, which is part of the Cordant solution that gives improves the performance of energy of all machines through digitalization, increase the uptime and reduce the risks, and also make a smart decision through the data-driven. So this is the Cordant ecosystem. Our Cordant ecosystem starts from the devices and the bottom layer, you see here. So we have thousands and thousands of instrumentation and sensors installed on all machines, from vibration monitoring, vibration sensors, temperature sensors, etc. And then we have the edge devices and intelligent automated hardware, like portable data collection, wireless data collection, or also the more advanced devices with continuous monitoring, like our 3500 or 660 devices. All these devices monitor the assets, all type of assets. We monitor all type of assets, from high critical equipment to less critical to low critical equipment. And all these equipments are connected to the system layer, as you see here, the software basically. So we have our production monitoring software that monitors these critical assets and less critical assets as well. And these are also connected down to the main digital platform, the Cordant solution, where it has multiple pillars, as you see here on top. It has multiple applications. We can add as much as we can, as much as we want. We can integrate with third-party systems. So we are creating one processing platform, digital platform, that we can see all types of applications. So we can, from energy sustainability, where we can monitor the emissions of the machines, from process optimization, where we can, the customer can look at the whole process, optimizing the process of the whole plant. That can also compare the number of value of it can increase the production, so they can adjust the process to see how much value of money they can make. And also we have access to performance management, where it has also some of the pillars. It has the Cordant Asset Health that we presented here as part of the asset performance management. We have asset strategy also, and we have the different lineages. So asset strategy can integrate with the CMS ERP system, the maximum SAP. It can give an indication to the customers how to optimize their asset management. So they want to change their plan outages and all. We can do that. Defect elimination as well can be through root cause analysis, defect to detect the failures and prevent. On top of the layers, this provides services that we do. So we have consulting services, we have full fleet of engineers, locally available and globally available. We provide trainings. And this is compared our expertise to the customer to ensure that they can manage all the systems and software by themselves. And we are there to support that. We, as we said, also integrate third-party engineers, so we can add OPC whatever the customers want. Even on the second layer, you see here the Cordant, we are reducing the artificial intelligence and machine learning. And party from customer, they have their own artificial intelligence machine learning model, and also NVIDIA that to our platform. So what challenges we address? So basically, customers, most of the plants, they have to be free, whether in the same, let's say, refinery or multiple refineries. For example, KMC, they have their alignment, they have Quebec as well, and in each refinery, they have multiple assets. So we here, we combine all these assets into the same platform. So when you open the border, you will see some globally. You will have a map where you will see where is the location of your fleet. And in each area, you will see you can get down and see which machines is creating the alarm. So that gives you a full management of your fleet and notification on which machines you need to look at. So that's in terms of looking at the fleet, and also some of the fleets you have measurable equipment size, so each equipment, if it's connected to some are connected to continuous monitoring devices, others are connected to offline monitoring, so multiple devices. And here it helps you also to quantify actually the repair differences. One of the things that is really important, we monitor the machines, we are able to protect our machines, but at the end it's really difficult for the customers to really quantify how much is the return differences, how much we are saving in terms of value, in terms of money. And this information is really important to customers. So with this kind of solutions, we will be able to know how much time you save, how much downtime you prevented, and how much value you save for the company. So this is now we start to talk about the whole Cordant solution, where we first Cordant asset level and asset strategy and effect elimination, process optimization, sustainability, all those modules. Those are part of the holistic ecosystem of Cordant. And Cordant, there are various modules, so each module can work separate, or they can all work together. So the customer can choose which module they want. And here we talk about the module of asset health. So the asset health is built on System 1. System 1 is our main condition monitoring software. It's a very here in Kuwait and Digitalization. So we cover all of that through System 1. System 1 collects the data continuously from devices that are connected on the machines, and gives this is a tool that is used by experts to diagnose and identify the failure before it happens. So it helps the customer to optimize investment and everything. But it is used by experts. So the experts need to use the software to analyze and detect it. Of course, there are alarms, there are data, there are everything that is unique to help you to optimize the process of the assets. But now we're taking this to another level. So we are using the software, the data that is taken by System 1, the high resolution data, we are taking it to a higher level for using the artificial intelligence and machine learning to give you an automated detection of failure. So basically, this is an example of what we are talking about. So this is the current traditional way of working, which is not wrong. This is a good way of working. We model the current, as you see here, on the green technology and just to know the difference of action that we're taking in green technology and human behavior. So we are using monitors, detections, using the attention sensors and devices and all to give you detection of the anomaly, and then it takes the software, the System 1 example, or whatever software you have, to analyze these data, diagnosis, and then it goes to implementation. So from the experts will extract from this data, and based on that, he will recommend action. So this is human, okay? And then it goes to experts. The recommendation of this action is also to go for another level of experts, take action, and initiate the work to maximum or to staff. And then goes the action in the system. So this is the current way. Okay. What we are taking to another level. So we are combining the monitor, detect, diagnose, and recommended action. We are adding artificial intelligence, machine learning, plus the physics-based analytics. So it's not only artificial intelligence. We are also using our own expertise as they can use this technology. We have more than 60 years of expertise. So we are using also our expertise with the physics-based analysis, the equations that is built by our expert, along with the artificial intelligence and machine learning. So this is gives you an automated results. This automated results will go with the recommended action. Now we are also adding another. This is ongoing now in the future. Hopefully. So this is we are adding also agentic AI. Now this is the generative AI, where that I see ChatGPT and all. This is considered generative AI. It learns by time, it analyzes the data, but going forward, the future, everything not only here, we have agentic AI. The agentic AI it's a model of expert. It's a person, basically, a person, but it's an artificial intelligence person. So it is AI that will take over the person and give you the recommendation based on the analysis that happening. Of course, after all this is not enough. You need the intervention of the human method. And once you get the results, you will not take it 100% and use it. So you need someone to verify and confirm the data that is taken. But of course, this has saved a lot of time from the engineers. So we are not replacing us, we are not replacing human, but we are helping the human to take a faster decision. Currently, you are using the experts, you analyze the data, and the multiple person is looking at the data and analyzing it all. But now we are using artificial intelligence, agentic AI, to give you the faster recommendation. You take that faster recommendation, verify it, confirm it, and then issue the work notification and close the action. So this is just to show you what, how much data, more data you have, it can give you a better result. So here we are dividing this section into 3 pillars: detection, diagnosis, and perspective. On the first, on the left side, as you see here, the data available is only processing data. Okay. So basically, it can give you notification because this is using AI. So we are using AI. We are comparing how using the physics-based analytics plus the high resolution data available in our software, how much it can help more than normal software that can use only depending on only process data and artificial. So as you see here on the left side, using process data can give you the detection, okay, minimum detection, and the minimum diagnosis severity, and also of course the prospective action will be more of generic. On the second portion, we are adding additional data. So process data, and also we have some limited CMS data, maybe trended values, from system one, from another software, but this is trended data, and another high resolution. It also will give you some additional prospective action, additional detection. With the full software features that we have, System 1, with the high resolution data that we have, high dynamic data, so we get more details on the detection and more details on the diagnosis and more accurate on the perspective action. So our software is built on cybersecurity. So we use the system one software is available in every plant. It covers multiple devices, right? And it is on, let's say, if you're talking about IT, this is normally on the full layer. Okay. Now, the business lab, business normal offices, they use laptops and all, they connect directly to devices on the field. So they can get a higher level of network. In order to make sure that they are cyber secure and not connect directly to layer 2, we create something called replication. So we replicate the software that we have on system 1 on layer 2, we replicate it on the layer 3.5. And then from layer 4, they can securely access the layer 3.5, which is replicating already the layer. So this is, in general, the network architecture. This is a sample of network architecture and can customize depending on the customer availability of the network that they have. So here at the bottom, the machines with the sensors connected, and then these are the monitors that we use, like whatever I mentioned, like wireless devices or machine monitoring, continuous monitoring devices like 500 or 60. And then they are connected on system 1, the software, which is on there. Now, these are, as I mentioned, replicated in here. So these are replicated in the center here, okay, and they are 3.5. And then from there, we connect the Cordant. So Cordant software is not connected directly on layer 2. The software is connected on layer 3.5 on the replicated software. So to make sure that the Cordant will be built on cloud. So we are not allowed to connect and access the feed. So we access the software that is replicated layer 3.5. And of course, on the cloud, it depends on customer. We can use customer cloud, we can use our own cloud, we can use locally cloud. This is just a sample use case on how we could save eliminate the failure and save around 300K of cost. So this is a sample taken for hydrogen compressor, reciprocating compressor. So alarms were raised indicating suction valve wear and damage or their mechanic end of cylinder number 1. So this is the notification that came out from the code. So they received the alarm and it was indicating that there is a wear on the suction valve, damage or dirt in crank end of cylinder number 1. So there is a notification and it gives you indication on what is the problem. And actually, if you dig down, also you will see not only the associated failure, but it's also why this issue happened. So after that, of course, the experts they came and also validated the data just to make sure that this notification is correct, and they realized this actually is a correct notification. So if failure was not detected, it could have continued operation defective valve, and which could have resulted in increased power consumption and also maybe could have major failure in the future. So basically that's it. If you have any questions.
Thank you, sir. That was an insightful session. My question is on the ML model. If I understand, the ML model is incorporated on cloud, AWS, right? So how do you secure vulnerabilities on the machines from which the data is collected? That is question one. And I also like to understand, you said level 2 is where the data is being collected and the integration between AWS, which is an ML model, to the level 2 is only permitted. So how do you ensure data security and in terms of any vulnerabilities that will be incorporated because of cloud integration?
Thank you for your question. So basically, as I said, our first goal is always to be on cyber security, and that's why we have the replication model that we create. So we prevent the direct connection to the layer. So when we are on the cloud, we don't see the layer. Okay, so that's we see only the layer 3.5 or layer 4, which depends on the agreement with the customers on the IT, where they want to install the application. So the replication is copy-paste of what is on layer 2. We replicate it on the centralized location. Basically, let's say, give an example, KMCC. KMCC have and they are all having the same cloud. Okay, so we will replicate. We have, we can just random numbers. We have maybe 20 servers and 20 servers, 20 servers, okay, they are all layer 2. So we are replicating all these 6 servers and centralizing them. Okay, and layer 3.5 or layer 4. That should be recommended for all the plans. So all these will be centralized. Of course, optimized. We not put another 60 servers, but like maybe every 8 servers be in combined in one server, virtual machines. Okay, so they are all will be replicated at layer 3.5. And from there we are connecting to the cloud. Now the cloud, we are using the standard cloud solutions. So we are using Azure, or we are using AWS, or whatever. We are using custom cloud, or we are using our own cloud. And that's, of course, we are meeting cybersecurity standards and so on. I'm sure I answered your questions.
Thank you, sir.
Thank you so much for joining the hard work of the industry. The expertise on illustrated from data analysis support functions for the we are grateful for very forward-thinking vision to us. Sincere thanks for your time. I invite our President and General Secretary to come on stage. I invite our President to present Mr. Wale the show. Mr. Wale the garment. Mr. Mr. from India, technical businesses, Mr. Abdul from SchuF, and Mr. Wali from Bengal. Sorry, thank you, sir, for sharing expertise us today. To all our sponsors, the Technical University Committee and our valued members, thank you for making this event a great success. Mark your calendars for the 10th on October 14. We look forward to seeing you then. Please join us for the dinner in our hall. Thank you and have a wonderful evening.
Friends